This video will use the TS Trainer, Electrical and PLC Troubleshooting course. The TS stands for Troubleshooting Simulator. We are using one of the course's narrations in the following review of the basic troubleshooting steps. We will wrap up this video by showing you some of the course's circuits and software functions.
The best, most experienced troubleshooters rely on a systematic troubleshooting process to solve problems on today's highly complex control circuits. A good troubleshooting process is simple. 1. Investigate the symptoms. You must then try to identify the possible causes. 2. Test the system and verify possible causes. Once corrective action is taken, follow through by monitoring the operation to make sure you have pinpointed the root cause, then complete any required documentation. A closer look at each step. Investigate the symptoms. Be sure you understand the system. Gather any available documentation. This may be hard copies or information may be available online. Locate schematics, piping, and instrumentation diagrams, as well as loop sheets. Talking to the operators and anyone else familiar with the operation may provide needed information. Pull all operations and maintenance records and control and configuration parameters. This information may be available from a PLC or DCS or other online databases. Generally, you won't know where the problem lies. Because of this, keep the big picture in mind. Start by breaking down even the most complex system into the 5 elements that follow. 1. Process controller, most often involving a microprocessor. 2. Input field devices, sensors of some type that monitor the process. 3. Output field devices, drives, valves, and alarms that receive a command signal from a control element. 4. Connectivity elements, wires, cables, and buses. 5. Process materials. 6. The people who can affect the process and its control system. Since the wiring and the inputs and outputs, I/Os, are the most vulnerable elements in a system, examine them first. While talking to people and reviewing information, look for a reoccurrence or pattern. If a pattern exists, is it related to shift changes, process changes, or any other reoccurring event? Use your own judgment on when to quit gathering information.
Let's apply the troubleshooting steps learned using the course's simulator. Step 1. Investigate the symptoms. The software provides a handy notepad to take notes as you troubleshoot. The Talk to Operators step is simulated via operator comments on the work order. The course lets learners familiarize themselves with the system via a circuit operation pop-up dialog box. Now that you know how it is supposed to work, test the circuit for proper operation. To view the documentation within the course, click the Circuit Diagram button. When we tested for proper operation, we saw neither light turn on. Consider possible causes while reviewing the circuit diagram. A best practice is to test your meter before starting the troubleshooting process. During that process, you may discover one of the most common causes of failure: power, like a blown fuse. Tip: test the meter twice, once with neutral and again using the ground. In this troubleshooting exercise, we find that there is no power reading for the incoming power line L1 to neutral. Next, to verify, we measure L1 to ground. Then, surprisingly, we see power. From these 2 tests, we can deduce that the meter works and that we lost neutral to the circuit. So we found the system fault while testing the meter, and it only took a minute. The TS Trainer Simulator requires students to first lock out and tag out the power before fixing the fault. The student will then select from the list of faults the one they found to be causing the problem. Choosing the correct fault will automatically fix the simulated fault. After fixing the fault, the lotto tag must be removed, and the power must be turned back on. The next step is to test the system and ensure everything works correctly after repairs. Students can open a list of circuits and see which ones they have already solved faults on. Next, let's look at some of the circuits included in the TS Trainer course. It starts with the most simple of control circuits, then moves on to the motor control circuits, finishing up with the more complex PLC faults. Both single contactor and reversing motor control circuit faults are available. The PLC circuits students will troubleshoot also increase in difficulty. The student starts with the first PLC fault in a brick-type PLC before moving on to the more complex modular PLC faults. We hope you like this video. Please go to ben95.com to learn more. Thanks.